Ladies and gentlemen, welcome to our webinar. Thank you for joining our Digital Week series. What do you need as a manager to know about business analytics? And how do you then turn this knowledge into action? I'm very happy we can discuss these questions with Professor Ivo Blohm today. Ivo is Professor for Data Science and Management at our Institute for Information Management. Before I welcome him here, just a couple of remarks for those who are joining us for the first time. We will, of course, record this session and then distribute the link next week along with the slides. Also, we will have plenty of time to discuss your questions afterwards, after the around 30-minute presentation. Please type in your questions in the F&A or Q&A field in your Zoom program. Depending on your software version, you can also upvote the questions you find most interesting. And you can even exchange amongst each other by using the chat. So now I would like to welcome Ivo. Thank you so much for taking the time. I wish you an insightful, it's not lunchtime, evening, and you have fun.
Hi, my name is Ivo. I'm Assistant Professor for Data Science Management. I'm very delighted to hold that webinar on business analytics for managers. So what do you really need to know about that? So I structured the webinar around 3 common myths that business people and managers frequently have when they speak about business analytics. And our goal for today is to tidy that up. Let's start with the presentation. Excellent. So what do we want to talk about today? The first myth managers and business people have is that they always think they have a lot of data. But in this webinar, I want to elaborate on that there are different types of data, and depending on your goals, this is very crucial to what you want to do. The second thing is that managers think, okay, we just need more data scientists to make that thing run. So, but in reality, there are a lot of different roles involved that you need to employ, and that you also need a lot of translation between data scientists and the business. And this is the second myth we want to elaborate on today. And the third one is that business analytics is a one-stop shop. You build up a data science team with a series of very, very talented people, and then the thing will happen. And of course, this is not the case, and I will want you to explain why is this the case. So in order to reach that goals, we want first to elaborate on what is actually business analytics, and that's the current understanding of that. What kind of ingredients do I need for making that happen in my organization, and how do I do that from a process perspective in the end? And there's a very nice quote from Hal Varian, who's the chief economist of Google, who said, 1 billion hours ago, modern Homo sapiens emerged. 1 billion minutes ago, Christianity began. 1 billion seconds ago, the IBM PC was released. 1 billion Google searches ago, that was this morning. And some of you already figured out where's that going to. When, of course, business analytics is somewhere about making all these new data flows analyzable in organizations to apply that to create value. But in order to do so, we have to tidy up a couple of concepts before we can dig into details here. The first thing is business intelligence. This is the thing that most of your organizations are doing today. This is storing structured data from transactions or business sales processes and so on in big data warehouses. And the purpose of that is creating reports of different kinds for supporting decision-making organizations. But if you take that quote from Hal Varian, a lot of changed. So it's about big data. From my perspective, this is about technologies that you need for collecting such huge amounts of unstructured data like search queries, to storing that and to make that digestible for your organization. Based on that data, you can then apply machine learning. And easy put, machine learning is the development and application of algorithms for detecting patterns in data. So machine learning finds useful information in data and regularities without being told to do so. And then I'm in the domain of data science. This is applying machine learning to everyday business situations, to business problems, or to improve decision-making. Finally, there's also the concept of AI. This is rather building applications around machine learning that may solve certain cognitive tasks that so I suppose that only humans can do with a similar performance, so such that these artificial intelligence systems seem to be somewhat intelligent. And now, for me, business analytics is to apply these new technologies and approaches to the domain of business. So big data, machine learning, and so on are just, well, generic technologies. They can be applied to any domain. For example, if you apply them to medicine, you're on the domain of bioinformatics, for example. But in our case, we want to apply them to business, so I coined that advanced business analytics. And maybe a small quiz. And so we have been talking a bit about business analytics, and maybe it's good to know where your organization is standing. So please answer the poll and say, where is your organization right now in the process of heading towards business analytics? Okay, so the first results are coming in, and it's more or less a normal distribution if we want to speak in data terms. And most organizations are somewhere in the phase of, well, we have started some pilot projects, and maybe a bit further down or further up the process, being or developing a data strategy, or, well, using that systematically in certain projects. But the interesting thing is that only a couple of organizations are using that large scale, very regular in all parts of their business models. These are maybe 7 to 15%. It's always the same pictures. And these so-called business analytics leaders are, well, very successful usually in their domains. Research has shown that these companies are more productive, more effective, more customer-oriented, and that really are tough competitors for other organizations. And the interesting thing is that these companies are, well, accelerating in what they do and become better and better because they gain more and different kinds of data with which they can improve their predictive models, as we will see in a couple of minutes. And the other one are still in the starting phase. So the gap usually becomes bigger between the one who are already leading and the one who are trying to achieve that. So I start with the presentation. And okay, before we can dig into these details about why these business analytics leaders are, well, heading away, we have to build a bit on our vocabulary. And building predictive models or applying business analytics is a bit like cooking. I need different kinds of ingredients. This is data. If I want to make a pizza, it would be the cheese or the salami or whatever. When I need some kind of appliance, that is an algorithm to cook the data or to cook the appliances. And then I need a recipe. A recipe is a model in data terms that tells me how to combine the different kinds of data in order to make a prediction. That would be the outcome of that task. This would be a dish, a pizza like that. And then finally, I have to consume it to use the predictions in our organizations such that it can create value. Well, in other terms, so sitting in front of a pizza with having hunger doesn't bring you any happiness, so you have to eat that until the full value of the pizza can be evolved. And when we look at data, a lot have changed in the last 15, 20 years, my friend. Up to the year 2000, data was something that was very structured in tables, had to do something with numbers. So if we think about spreadsheet, that was the original idea of data. Right now, data has been changed a lot. If we speak about data today, we speak about images, text, log data, and also this picture of a grumpy cat would be considered as being data today. And so we have to deal with a lot of different kinds of data. It's very unstructured, and that's one of the challenges here. Another thing that has been changed, that in the past, if we spoke about data collection, it was about surveys, interviewing people, and so you ask these guys, and then you get some subjective opinion or attitude about how they feel or perceive a certain circumstance. Right now, we are much more about tracking behaviors or decisions. So we use digital devices, and then we get that data, and this is tracked data. This is a revealed preferences. So in other terms, we can actually see whether a person has been working out, and we don't have to ask him, have you been in the gym or not? So in many cases, this data is much more accurate. And machine learning is, well, a bunch of technologies that is able to analyze such kind of unstructured and tracked data. and it's no uniform term. So that's about 100 possible algorithms. It's a very dynamic, evolving field right now. Every day, more or less, new algorithms hit the light of the earth. And so there are different types. In this webinar, we will shortly pinpoint on the two main types, unsupervised and unsupervised machine learning. And for business contexts, supervised machine learning is the major thing that is applied today. So I would estimate it's about 80 or 90% of business applications are in this domain. Sometimes you also read the term automated machine learning that is very hyped in the media right now. And this is basically about, well, automating the process of developing models such that can be done with greater ease. And for discussing what supervised machine learning is actually about, I picked out a nice example. So this is Cardiogram. This is a real app. You can look for that in the App Store. And the idea of that app is that it's tracking your heartbeat with an Apple Watch. And based on the heart rate, what is collected with the Apple Watch, you get a couple of recommendations, or in the most severe case, you get some alarm because your heart rate shows irregular pattern and you should see a doctor right now. And this app or this device tracks your heart rate on a second-by-second measurement. So it collects more than 100,000 measurements per day. It's collecting huge masses of data for each user. And based on that data that is collected, it has a neural network. It's a very powerful algorithm. And with that, it can predict with 97% accuracy whether a certain user has some heart rhythm problems or not. And so it's quite interesting because it's very prototypic for many, many fitness apps. So by using them, you collect data for their models. And if you make certain actions in the app, you can be pretty sure that you're training some kind of machine learning algorithm with that. So, and for training such machine learning model and to making that work, you need different kind of data. The first one, if you look at that from a customer's perspective, you need input data. So the customer needs an Apple Watch that tracks the heart rate. This usually works in optical fashion. So it's measuring the variability of colors in your skin, and that is associated with the heart rate. So if you're upset, your heart becomes a bit greener usually, and this is measured with that kind of devices. So you get that input signal on a second-to-second basis, and maybe you also have some other information that is collected during the subscription for that app, maybe the age of the person or the date of birth, the gender, and very high-level things of that. And with that information, this app is making a prediction. And making a prediction in machine learning terms, it's not looking into a glass bubble and to see what happens. It's basically a very simple thing. In this case, we make a very simple decision, yes or no, it's a regular heart pattern or it's not a regular heart pattern. And prediction is just the process of, taking the data I have, that is the input data, that is the heart rate data, that is the gender and age data from the subscription, and then to estimating from that input data whether this customer, this user has rather a regular or irregular heart pattern. So I take information I have to infer information I don't have, and this is all that prediction is about in this this easy classification task. And how does that work? If we go one level deeper into the technical details, when we have a data set, and also in the big data in machine learning world, data is still well organized in a tabular fashion that hasn't changed that much. And when we stick to that example here, we have data like that. We have maybe a user ID, we have the age of the user, we have its sex, we have the timestamp of when the heart rate has been collected, and then we have the heart rate in beats per minute or something like that. And with that table, so this information we have here are usually called features or attributes. There are many different other terms for that. Maybe you have also read of variables if you remember to your time at the university. And then we try to predict the heart rate pattern, whether it's regular or irregular. And that goal that we need to predict is called label or target. And this is what we want to predict. So we put that data into the neural net. And then the neural network, for example, is looking about, okay, which patterns in heart rate, timestamp, gender are associated with the different patterns of regularity of the heart rate. So, and how is that working in organizations? So we have first that a phase of data collection, engineering. This is collecting all the signals from the users with the Apple Watches to put that on a big database, to digest the data, to make that analyzable. Then we have that phase of machine learning or data science. And then based on that, an automated decision is delivered out. So should the patient be recommended to see a doctor or not? And when we have the labeled training data, we put that into a phase of model training, and then we get the model. So this is the recipe how the different patterns in the data have to be combined such that we can infer whether it's a regular or irregular heart rate. So, and then we take that model, take new signals, new data from a new customer, put that in the model, and for this guy, we then get a prediction whether he has okay heart or not. So, and a very crucial thing that you have to take away from this small deep dive here is that collecting input data is very cheap. Organizations have a lot of input data for such kind of organizations. But creating labeled training data, that is a huge investment, for example. In this Cardiogram example, they have teamed up with a university, and they made a long-term trial, and they followed 6,000 users over a long period of time with their heart rates and their heart diseases. And based on this data for these 6,000 users, so the entire neural net is trained, and only 200 of them developed some kind of irregular heart pattern. So, and this is why it's complicated, and this is why many organizations don't have enough data for training machine learning models, because they don't have labeled training data. And okay, let's assume we have now the data for the 6,000 users. We have built a model. We can predict whether we have some kind of heart rate irregularities among them. And now we need to check whether this prediction is accurate. So we then take the other users. Some of them are sent to the doctor, and then check whether the predictions has been true. This is called testing data. And then we have to reintegrate this updated predictions, the updated diagnosis of the users to our training data, such that the entire process can start again. So, and this is something that is also important about machine learning models, okay, that they only learn more or less if new training data or feedback data more specifically is added to that entire process. Well, another type of machine learning is so-called unsupervised machine learning. The goal of that is not predicting whether a customer has regular, irregular heart rates. The goal of this task would be to derive different segments of customers, for example. For example, this is a segment of older risk patients that have a similar pattern. This is a pattern or a group of young and heart healthy patients that have the same heart rate patterns, or these are some users that should go to the doctor immediately because they have some really strange things in the heart rate, and there's immediate call to action. So here the goal is not predefined. It's not about going to the right or the left direction to one of the two classes. Here the result could be any number of classes. It could be 3 different segments, it could be 10, or it could be 5. This is something that comes directly out of the data. And now we have a bit better understanding about how machine learning works, what kind of different types of data I need for that. And now the crucial question, how do I bring that into action? And this brings us directly to the second list. Usually there is some manager from a business line and said, okay, I want to use analytics, I want more leads, I want more operating profit, I want more margin, and we want to do that with analytics. This is the great hot shit, and we want to implement that in our organization. Then he's going to the data scientist, and then it fails, because in this picture there are 2 big thinking flaws. The first one is that the data scientist is not the one who does magic. He's not a guy who gets data and then he comes out with an awesome predictive model that has some notion of artificial intelligence. This guy is an engineer. He has to understand the domain of the business guy, how the processes are working, what is the prediction goal. Data scientists are, well, let's say, interested in questions like, is this a classification or a regression problem? What kind of algorithm do I need to know? How is data quality like? What happens after the prediction? And all such questions. So there is a high need for translation between the business people who want more sales and the data scientists who have to deliver that. And there has been a recent study by McKinsey, and they have find out that so-called analytics translators, these are the guys that have domain understanding from the business, but can also speak to the data scientists and the techies, are the most important factor of success for making analytics initiatives run. The second big flaw here in that picture is that there is no that data scientist that can do everything. If you have such kind of projects like the Cardiogram app, you need a couple of different roles. It starts with data engineers. These are the ones that make data flow. So if data scientists are the data wizards, data engineers are the plumbers of data. They make data flow, they collect the data from all the different devices, they store it in a distributed database in a secure, non-redundant fashion and make it analyzable. The second big group of people what you need are data analysts. So if your business has certain questions, okay, how are people using our app? How do older patients or users diverge in their behavior from younger ones? Do the ones who have irregular heart rates use our app differently? And all of these questions are not answered by data scientists. These are answered by data analysts. They have a very good business understanding and deliver the facts for decision-making that business people need. And finally, we have the data scientists, or the term that I like much more, machine learning engineers. These are the guys who actually build these neural networks, who build predictive models, who evaluate them and deploy them in practice. And this is a thing that business people should know, that just adding more data scientists to the team or to the business unit doesn't bring you any further, because they lack the competency of the other two people, and so it won't be any successful. And let's make a second to Paul. What do you think of the three roles: data engineering, data analysts, and data science machine learning? Which of the skills is most important and most wanted in organizations currently? Okay, well, it seems that data analysis and the data science are making the race. And the pattern is not changing. And this is pretty wrong, and it's a current belief of most organizations. I think if you take that pyramid over there, data engineering is the bottom layer. Without proper data engineering, nothing else is working, because data scientists and data analysts don't have access to accurate, up-to-date data and cannot do their job. Then all ad hoc queries, current things that people want to know in the business are usually answered by data analysts. And then on the top of the pyramid, you need data scientists, machine learning engineers. So this is rather the small fraction of what you need for making that. Well, so let's close that, Paul. Okay, so, and if you want to bring that in action, you do not only have to put these different roles into place. In reality, there are much more of them. So I think up to 25 different data-related roles, also for people like me. It's very difficult to, well, see the differences between them, but this is something you as a business person has to navigate through. And then let's assume that you have these roles in place. You have to go to always say a three-step process. First, there's always some kind of exploration. So this is about identification and evaluation use cases, and then to build pilot projects around that. You have to be very agile here, because, well, such kind of data-related project is much more like a research project and not like a software engineering process. It's not like that you have certain requirements and then the software engineers will come up with the solution after a couple of weeks or months. So it's, you have an idea, and we maybe have the data, and maybe it's working out, but we don't know yet. So the result is not guaranteed, so you have to be very flexible here. And the analytics leaders usually set up a quite big pipeline. So every year they start about 10 to 20, maybe even more, pilot projects and only a very, very small fraction of them does then make the next step. I once read that Google has currently about 1,000 different projects in the exploration phase, and maybe 10 of them hit the litmus test of reality and go into the next phase of technical production. In the phase of technical production, so the goal is to set the pilot project in a, well, let's say, real-time working environment that is live, that is operating. So there are a lot of questions of infrastructure, data security have to be solved. Data engineers become very important in that phase. Then you have classical IT and software development folks that have to be involved if you want to integrate that in your products. And finally, you have to set up operations. This is going along with a couple of new roles, like you have to do risk management for your models. You have to have people that check whether they're still accurate, whether they're still working, whether they deliver their goals, and so on. And at the end, so it's a huge phase of organizational change. So if you take that serious, you have to do a business process redesign. I know this term is very 90s, and a lot of consulting agencies earned a fortune with that, but this is the thing that is coming in the next 10 years. So that you have to redesign all your processes, all your decision-making processes based on data, based on principles of AI in order to make that happen. And the business analytics leaders, so that small group of 7 to 15% of companies that are leading in that field usually invest up to 90% of their entire analytics budgets into the last phase of organizational integration, to make the last mile, to bring the predictions to the people who need them and to deliver that into the project. So business analytics is not a one-stop shop. I just set up a prototype and that's it. Rather, you should consider it as a change process, as a marathon. This has to involve the entire organization in order to make that really successful. Okay. So, and if you're a manager and you maybe have to push the question, okay, now we have a bit better understanding of 2 or 3, let's say, common myths and flaws many people tap into when they start to engage in that area. So, but what do I really have to know? So the first thing is that you have to develop kind of business understanding of how data is changing your business. So this is a lot about digital strategies, how data is integrated in your products, how the digital business world is diverging from the old traditional physical one. So I think you will see a lot of food for thought here in that digital week for that. So I won't to dig into details here. The second one is that you have to understand the perspective of a data engineer. So how do I collect the data? What are infrastructure choices? How do they affect my business? So it could make a huge difference whether to host all that data in-house or to go in the cloud. You have to set up data governance and data quality management processes. So there's a lot of what you have to understand in order to make or to use data as a strategic resource. Then, and I hope I could clarify a bit here in that webinar, is you have to speak big data and AI. You have to be able to make the data analyst or the data scientist understand. So what is your ideas about? What is your goal? How should analytics support that these guys are not tapping in the dark? And so you're well supposed to get a bit of the analytics translator here. And finally, you have to be able to redesign your organization, you build a data-driven organization, and to bring that into life. So what do I want you to remember from this webinar? So if you go away to lunch or whatever you are up to this night, so I want you to remember 3 things, and I think this is important. The first one is that data is not data. For building machine learning models, you need different types of data. So you need input data. This is the data you need for make predictions to your customers. So remember the hard signal. Then you need training data, or more specific, label training data with which you can build a machine learning model. And obtaining labels might be very, very costly. And then you need feedback data with which you can check your model, the quality and its performance, and constantly update your prediction model. The second thing is that there is no data wizard or data scientist that is a magician. So there are different roles involved, and you have to find a good blend of them in your organization in order to make that happen. And finally, you should consider that as a strategic initiative to change, in which many people have to change their roles, their understanding of data, and potentially also the way they make their decisions. So that was from my side. Maybe there are some questions. I would be very eager to answer them.
Thank you, Ivo. This was very insightful. I'll just stop this screen sharing here. There we go. Thank you for the first questions. We have a few here. I'll start with the last one. What classic roles or know-how backgrounds are best suited to be developed to each of the three mentioned roles?
Well, so I think the data engineer, so this is very similar to the classical roles like enterprise architecture, data architecture, solution architects. So these are the job titles from the old world, and these guys have to develop to the new, let's say, technologies for storing big data. So this is about distributed databases and so on. And I think this is the most important from my side point of view, and also the resource what is most difficult to get on the market right now, because it's not so hyped like the data scientist and so on. And in terms of data analysts, these are basically the guys that are data analysts today in organizations, and they are quite eager to develop in the new world. So I think this is not the biggest problem, to just have to be aware that you still need that guys in the new world as well. And in data science, this is maybe the most difficult right now, because there are a couple of university programs from universities, but they have been started 2 years ago, 3 years ago, and there's no so much let's say supply on talent right now. But many people from let's say math savvy fields have to develop in that role. And most data scientists I know that are really well settled are coming from the field of physics, because these guys are very math savvy. They are used to work with huge data sets. Let's think of CERN. They have some ion colliders, and then they collect everything they get because the experiment is so expensive, and so they are very frequently set up. But I think this will change in the next couple of years, and I think then it will even out in terms of supply and demand.
And how can you educate traditional senior management with no understanding of this world of business analytics, apart, of course, from watching our webinars?
Okay, well, I think I think it's very, very, let's say, important to senior managers to go to some kind of end-to-end experience. So this is a data set, and this is a simplified algorithm we want to apply. This is the training data. So now we train them, and so we evaluate them to just give them understanding how this works and what let's say problems can occur in the process, because it's very, let's say, abstract for such people when a data engineer is saying, okay, I have been tidying the data for 3 months, and now we can start. And then why does that take 3 months? I think this is a very important point. But once they have sitting in front of a computer and were asking themselves, okay, I have this data in this format, and how do I get it in the other format, and fail with that task, they have a complete different understanding. I think this is something that is quite crucial to get rid of all the AI PowerPoint presentations, to just go to the computer and to try that out. I think this is very important.
It's a question that ties right into this. How can I get the funding from management, knowing that there's a long lead time from exploration to results? Managers want quick results. Do I just need to train them? Or?
Well, this is I feel this is a very, say, difficult question. So because many high-level management expectations are inflated. So I give you a bit of money when you develop a big use case, and when you will bring back a fortune of revenues or something like that. And I think the first and foremost thing is that you find a use case that is quite sure that it will succeed. And a very good colleague of mine is head of analytics for a big Swiss company and had the task to start that thing in this very traditional industrial organization a couple of years ago. And he had so fancy ideas of what could be done. But he started, as he said, with the most boring use case he could imagine. It was sales forecasting. And he took that because this is a big pain for the organization. Everyone uses that and has a very pivotal role. And then he built a model and he made some kind of a bet with these guys. Okay, let's take that data scientist here and let's invest 3 weeks of time and we will build a model. And after these 3 weeks, we will make the predictions about sales. And then we store that, we put that in a safe, and 1 year later, we meet again. You do whatever you do on like all the other years, and then we compare. And he was able to show that his models were much more accurate. And so he had huge management buy-in for all the other things he could do. But for me, the important thing is that he were not explaining how good his models were or something like that. He were going to the things that were important to his stakeholders. And that was the accuracy, for example, of the sales model or how much money he could save. And this was what these guys could understand, and not my model has an accuracy of 97% or so.
Yeah, thank you for that example. And how can small and medium-sized companies even succeed in this vast and complex context? And where do they get the talent they need?
I think, well, it's the question has 2, let's say, levels. The first one is how to get talent. And every organization I meet, I ask, do you have problems finding data scientists? And I get a very nuanced answer. It's either yes or no. If you are, for example, if you ask, for example, Post Finance, and this is a Swiss bank in Germany.
That's a rather big
company. And these have about 90% of all payments in Switzerland. And this is some data set each data scientist is loving to work for. And they have said, no, it's so easy for us, we just make an opening and we're drowning in applications. If you are, well, let's say tier 2 or tier 3 organization, then it's getting very hard to find good data scientists. And all organizations I know have been a good job were spotting, okay, who is a guy who is math savvy, who has some background in math, physics and something, and who wants to develop in that role. For example, if you look at Festo is an industrial company from close to Stuttgart, and they are doing exactly this. They say, okay, we don't have any chance getting good data scientists. They go to Daimler or whatever, to Bosch. And for us, being a supplier of these organizations, it's very hard. And so they looked about, hey, what kind of people do we have who wants to develop here? And we give them training, and they are super successful with that approach. So they have been winning a couple of big data and data science prizes from different industry organizations. So it's working also here, but maybe the way is a bit longer here.
Thank you, Ivo. Here's a question about definitions and terms. Is business intelligence more in the back-end processes and business analytics in the front end? Or are there examples, especially in regulatory processes, where business analytics is used?
Well, I would say business intelligence is very defined and structured in organizational divisions and so on. And so it's very common standard. Business analytics it's maybe a bit more explorative. So in business analytics world, you have usually fixed reportings every month. Every stakeholder gets this kind of report. And business analytics is much more ad hoc right now. And it's dealing also with going beyond building reports, building database products, and this kind of things.
Thank you. How can I validate a self-learning system?
Well, the best way of doing that is a very, very straight thing to do. So let's make some kind of A/B test, for example. You have a business process, a product, or whatever that uses that self-learning system. You define an outcome that you want to observe, and then you compare these outcomes with a similar project or similar business process without that thing. In a perfect world, you have 2 identical things that you can compare, one with the self-learning system, the other one without, and then you can see the outcomes, and that is still the gold standard here. Beyond that, there are a couple of, let's say, technical measures with which you can determine how well data fits to the model and how well the model is performing, but the lactate test of reality is still the best thing.
Thank you. And how do I make data cleaning and data labeling operational? How do I implement this in a cost-effective way? Are there supplies around this topic, or do I need to employ people?
Well, there's a huge industry developing around that. For example, you could go to, if you need labels, for example, you could go to services like Crowdflower. They go through thousands of text, for example, and when they rate what is happening with text, then you can train your models on that. And beyond that, I know a couple of organizations who are rather using offshoring principles. For example, I have spoken to a very well successful company in the domain of risk management. So they scan all blogs and newspapers that are relevant for supply chain management. And then they have a data polishing center in Poland, for example, with employees who go to all of these articles and say, okay, are these relevant for supply chain management? If so, for which of our customers? And so we are creating that labels in a manual fashion, and it's very tedious. Beyond that, there is, processes for automatically creating labels, and they work sometimes quite okay, but this is rather a more complex thing. But beyond that, so data quality management has been an issue for 30 years in many organizations. And so it's still a lot of open research questions here. So it's still a task.
So people will still be needed in that area. On slide 23, you suggest that the rollout is a sequential process with change management at the end. From my experience, change management is very important, and I would strongly argue that change management has to take place in parallel to everything else. What do you think?
Yes, this is a good one. So actually, it's true. The thing is, well, the sequential process has the idea of some kind of pipeline. You start with many pilots, not all of them will go into production. For once that go into production, you will need change management. And I think here you are true. So you should start change management maybe directly with that. But I think it would be, well, exaggerated to start a huge change management campaign for each pilot when it's still unknown whether it will work out or not.
Here's another one on change management. What is the typical timeline to lead the change management through the 3 steps of exploration, technical production, and organizational integration? For example, an example of global manufacturing company based on SAP and Hyperion, having a few databases available, mainly relying on a business warehouse still.
Okay, so I think this is very hard to answer because each organization is different, but I can give you a real world example from a friend of mine who is a data scientist for a big German car manufacturer. And he has been working on a model with which he could predict whether the screws are correctly drilled into the car directly after the screw has been drilled. And he was using the sensor data of the, I don't know how it's from the machine that drills the screws into. In German, it would be Akkuschrauber. And he was using that signals, and directly after the screw was in, he could say, okay, it will fail after 1,000 kilometers or whatever. And he was developing that model in, say, 2 to 3 months or something, when it was good. Then he had some kind of exploration phase that was 6 months, where that was still okay. And then they decided to roll out and building some kind of, well, let's say, industrial application for that. What was okay for all the standards of that big company was about 2 years. So it gives you an idea about how difficult it can be to bring that into production and do the change management with that. But generally, I think the companies that are most successful here are going rather for 80% solutions, because it's a lot of work to build an 80% solution, but it's much more work to go to the 100%. And if you invest that overhead into the next 80% solution, you get a much bigger outcome. That's my personal opinion. But of course, not in each and every context, it's okay to go with the 80% solution. And this is also why, from my personal experience, because marketing and sales are the biggest application domains right now for many organizations, because if you fail in these domains, failure is not costly. So if you fail to predict a customer correctly, he gets an email he shouldn't get or something like that. But if you're in some kind of industrial production process, or even worse, in the domain of healthcare, where failure could mean a death to a patient, so it's much more difficult to go for such kind situations.
Well, thank you. I'd say let's not keep everyone from dinner for too long. So one question, getting back to the topic of what managers must know. Garbage in, garbage out. How can a senior manager get assurance that the data quality and analysis was up to a certain standard?
Well, this is of course true. Well, I think there are some kind of techniques that can cope with bad data quality, but the potential of these techniques are limited to a certain degree. So but the most crucial thing is to just try out. So sometimes you can do very nice things with data that is bad, and sometimes you have any chance because it's too bad. But my suggestions would be, okay, let's define a certain budget. Let's say the data scientist working for 1 week on that and is building a prototype that has to be working after that week, and then we re-evaluate. Is it worth going into that direction or not? And I think this is the most crucial thing, and this is very much the explorative character in the first phase of that. Even it's not really sequential, but that simplified model.
Thank you, Ivo. Thank you, everyone who was viewing, and we also had a few listeners. Do you have any final remarks? Anything you would add?
No, I hope you enjoyed the webinar. I hope you learned something new, and so enjoy your evening, have a nice dinner, and look at our next webinars that are upcoming in the next days.
Yes, same for me. Enjoy your evening and hope to see you for upcoming webinars in the next 2 days. Bye-bye.